Hello and welcome to notes number 3 on multiplying and dividing with scientific notation. So up until now we've learned how to write numbers in scientific notation and how to write them back into standard form. Today we're going to take a look at how you can multiply two numbers while they're in scientific notation. Before we do that, I have some exercises I'd like you to try that's really a review of what we did before when we were multiplying with exponents. We've got a few expressions here with numbers and variables, and practicing this is going to help us with multiplying scientific notation. So in the first example, we've got 5x squared times 7x to the third. And if you remember, when you multiply expressions, you're going to multiply the coefficients, and then when you multiply like bases, we can add the exponents. So in this case, 5 times 7 is 35. X to the second times x to the third is going to be x to the fifth because we add the exponents. Okay, so let's try that again with the next example. Here we're going to have 12x to the third y times 3x to the fourth y. So first we're going to multiply 12 times 3, and we're going to get 36. X to the third times x to the fourth is x to the seventh. Y to the first times y to the first is y squared because you add the exponents when you have like bases. Okay, so when you multiply expressions, you multiply the coefficients and add the exponents of like bases. Now when we divide expressions, it's similar, except we're going to divide the coefficients. In this case, we have 24 and 6, and subtract the exponents of our like bases. So 24 divided by 6 is 4. X to the 7th divided by x to the 5th is x to the second power, because 7 minus 5 is 2. In the last example, 36 x to the 5th y divided by 9x squared y. 36 divided by 9 is 4. X to the 5th divided by x squared is x to the third, because 5 minus 2 is 3. And then y to the first divided by y to the first. If we subtract the exponents, we would get y to the 0 power. But we know that y to the 0 power is 1. So we can simply write 4x to the third. Now the reason for reviewing this is when we multiply scientific notation, we do exactly the same thing. So when we multiply numbers in scientific notation, we are going to multiply the coefficients. So right now I'm looking at the box on the left, the steps to multiplying numbers in scientific notation. What's going to happen is that we're going to multiply the coefficients. And the coefficient is just like the coefficient with our expressions. It's a number multiplied to the power of 10. And once we do that, we're going to add the exponents. Now, once you've multiplied the coefficients and added the exponents, that are the powers of the 10, you need to look at your result. Sometimes your final answer will not be written correctly in scientific notation. The coefficient might be too big or too small, so you might have to rewrite the result to scientific notation. Okay, please be sure to write that into your paper as well. Okay, so let's take a look at the first couple problems here to apply what we've just talked about. So in example number 1, it has two numbers we're multiplying, two numbers in scientific notation we're multiplying, 4 times 10 to the 9th times 7 times 10 to the 4th. Okay, so here I'm going to look at the coefficients. I have 4 and 7. So I'm going to multiply the coefficients. I'm going to multiply 4 times 7. And when I do that, I'm going to get 28 times, now I have the powers of the 10. I did like bases. So once I have like bases, I can add the exponents. So it's going to be 10 to the 13th power. 9 plus 4 is 13. Okay, that's all I had to do. But now I'm going to take a look at my answer, and I see that my 28, which is the coefficient, is too big. The coefficient is supposed to be greater than or equal to 1, less than 10. So now I'm going to have to rewrite my coefficient. So I'm going to rewrite my number. I'm going to, instead of 28, I have to put the decimal after the first digit. So it's going to be 2.8 times 10 to the first. I only had to adjust it one decimal place. Times, and I already had a 10 to the 13th. Okay, and now I can simplify that. And I've got 2.8 times 10 to the 14th power. And that would be my final answer. So once you multiply the coefficients, add the exponents, you want to take a look at your result to see if it needs to be rewritten so it's correctly written into scientific notation. Okay, so now I'd like you to press pause for a moment and try number 2 on your own. And then when you're ready, you can restart the video to see how you did. Okay, so again, in this case, I multiplied the coefficients, 5.1 times 2, and I got 10.2 times 10 to the negative 5th power, and negative 5 because negative 8 plus 3 is negative 5. But then I saw that my coefficient, 10.2, was too big. It's got to be less than 10. So I rewrote the coefficient as 1.02. The decimal has to be after the first non-zero digit, times 10 to the first. And the exponent is just 1 because I only had to adjust it one decimal place. Then times 10 to the negative 5th, which we had from before. So I simplified that to get a final answer of 1.02 times 10 to the negative 4. Okay, so now let's take a look at what we would do in dividing. So now let's take a look at the right side of that box up top, steps to dividing numbers in scientific notation. So when we're dividing numbers, just like when we had expressions, we're going to divide the coefficients. Then once we divide the coefficients, we're going to subtract the exponents. And again, as before, once you've done that, you want to stop and take a look at your answer. Sometimes the result might have to be rewritten so that it's correctly written in scientific notation. Sometimes you might not have to. So you definitely want to check to see if you have to rewrite the result to scientific notation. Okay, so now let's take a look at how we can use that in our examples down here. We have question number 3. We're dividing two numbers in scientific notation. So let's divide the coefficients. 2 divided by 5, well, it's actually going to be less than 1. 2 is smaller than 5. So when you work it out and do 2 divided by 5, it turns out to be 0.4, 2/5 or 4/10. Now when we divide like bases, the both base of 10, we're going to subtract the exponents. So and we're going to subtract 8 minus negative 4. I'm writing this out because it's got that double negative. Because we got that double negative, you're going to have to clean that out. And it becomes plus. So when we work that out, it's going to be 0.4 times 10 to the 12th power. So we divided the coefficients and subtracted the exponents. But now I see that my coefficient is too small. 0.4 is less than 1. That's not okay. So I'm going to rewrite this. So I know my decimal has to go after the first non-zero digit. So I'm going to write 4 times 10 to the negative 1. My exponent has to be negative because 0.4 was less than 1. And then times 10 to the 12th. And now I see I'm multiplying like bases. So this is going to be 4 times 10. I'm going to add the exponents to the 11th power. And that's my final answer, written correctly in scientific notation. Okay, so now press pause and try number 4 on your own. Okay, so now you see I divided the coefficients and got 0.5 times 10 to the 7th because 9 minus 2 is 7. But then you notice that the 0.5 is too small, so we had to rewrite that. The decimal has to go after the 5. Since 0.5 is less than 1, the exponent on that 10 is going to be negative. 5 times 10 to the negative 1. And then we simplify the tens. So we have our final answer, 5 times 10 to the 6th power. Okay? So again, we have 2 more problems I'd like you to try, and I'd like you to read through those. I'd like you to read through those on your own. Set those up. Try a solution, and then once you've tried that, you can check your answer. Okay, so for number 5, we are finding the area of the stadium, a rectangular stadium. So whenever you find area, you multiply the dimensions, length times width. So you're going to be multiplying those 2 numbers. Try it on your own. And then in number 6, you're going to be dividing, because anytime you want to know how many times bigger something is than the other, to know how many times bigger, you divide to see how many times it goes into it. So again, you're going to divide those 2 numbers, try it on your own, and then in class, I'll let you know what the correct answer is. Thank you very much.